All right, so now we're going to do the Beer-Quiche game. And the Beer-Quiche game is a type of dynamic game of incomplete information with signaling. Okay? Now, a signaling game is a type of dynamic incomplete information game involving two players, a sender and a receiver. Okay, so a signaling game is a dynamic game of incomplete information involving two players, a sender and a receiver. Okay, and the signaling game has a certain sequence. So the timing of the game is as follows. Nature draws a certain type, Ti, for the sender from the set of possible types of sender. T equals T1 all the way T capital I. Okay? According to a probability distribution P Ti, where PTI, where PTI is greater than 0 for every I, and PT1 plus PT capital I is equal to 1. Okay, so what all this means is that the sender has different types. So he's either strong or weak, or nice or mean, or rich or poor. And which type is drawn in the game, or which type is in the game, is determined by nature. So nature draws a certain type Ti for the sender from a set of possible types of sender. And T, capital T, the set of possible types of sender, is the list of the types that the sender could be. So if he's either strong or weak, then capital T is either T1 or T2. If he's either strong, weak, strongish, weakish, then capital T is T1, T2, T3, T4. Okay? And this is drawn according to a probability distribution PTI. So PTI is the probability of the sender being type Ti. So for example, if there's a 50% chance that the sender is strong, then Ti being strong is equal to half. Okay? And so basically PTI is positive, it's greater than 0 for every type. So every type is possible. Every type has a positive probability, and the total the sum of all the probabilities of all the types is equal to 1. So if the probability of the sender being a strong type is a half, then the probability of sender being a weak type is 0.5. If the probability of a sender is 0.2, then the probability of the sender being weak, being strong is 0.2, then the probability of the sender being weak is 0.8. Okay, so all this is saying is that nature draws a type for the sender, and that type is drawn from a set of possible types for the sender, and the set of possible types has different types for the sender, each of which can exist or can occur, or nature can draw according to a probability distribution where there's a positive probability for each type of sender. So each type of sender is possible, and the total of the probabilities of the types of senders is equal to 1. Okay, and then the next step, the receiver, sorry, not the receiver, the sender. So remember, the first step, nature draws the type Ti for the sender. So the next step, the sender observes Ti. So he observes, or he or she observes the type that nature has drawn for them, and chooses an action, or in our case, a message, Mj, from a set of feasible messages, capital M, which is M1 all the way to Mi. Right? So what happens here is that the sender observes the type that nature has drawn for them, and then they choose a message to send, Mj, from a set of possible feasible messages. Okay? So the sender could, if nature draws a strong type in the Beer-Quiche example, then the sender can choose a message from the set of possible messages, which is either to order beer or to order quiche. And he chooses that from the set. So in the Beer-Quiche example, the set will be order beer or order quiche. That's the set of messages that the sender could send. And then the sender would observe Ti, which is their type, and then they would choose a message accordingly. So the next step, the receiver observes Mj, which is the message sent by the sender, but not Ti, right? So the receiver observes the message, but does not observe the player's type. It does not observe, the sender's type, not Ti. And then chooses an action, AK, from a set of feasible actions, which is capital A1 all the way to A capital K. Okay. And based on the receiver's choice of action, both the sender and the receiver get a payoff, and their payoffs are given by the utility of the sender, which is a function of TI, MJ, and AK. And the payoff for the receiver is the utility of the receiver, which is also a function of TI, MJ, AK. So depending on what the sender's type is and the message they decide to send and the receiver's action after he observes that message, both the sender and the receiver's payoffs are determined according to that.